Hello, my name is Ulises Castillo. I am part of Group 22, and in this video I will be going over the code, the LabVIEW code that makes our project run. So here's the front panel. We have it separated into about 5 different sections that are each labeled. So this bit is the role reveal at the beginning of the display. So all you need to do for this part is select the file that includes the correct sound effect and let the Arduino know, or let the LabVIEW know, code know rather, which digital output pins are connected to your hallway lights. So these are the wave of lights that turn on sequentially. In our case, we had them connected to 6, 7, and 8 output pins. And the sample start position and samples per read you can leave at 0 and 3000 respectively in all of these cases. Same basic concept for storage task sound. You put in the file location for the storage task sound. Um, Electrical kill, once again you input the file location, and in this one there are some lights in the electrical room, so you would put the digital output pin that corresponds to those lights. In our case, the digital output pin we chose was 10. And similarly, the emergency meeting occurrence, choose the sound effect, tell LabVIEW which digital output pin you chose for the lights that are present in the cafeteria. For us, that was 11. And then you input this a string into this LCD text box of whatever you want it to print. So in our case, we wanted it to print blue was ejected. You could also choose, red was ejected, whatever you want. And then here you have a clockwise counterclockwise switch. All this does is change the spin direction of the fan that is included within the storage task occurrence. And we usually just keep it on counterclockwise. And this last bit is just an indicator that lets you know how far you have moved the joystick up or down, as well as a quick little guide of the limits for the reading up and down. So it goes all the way down to 0 and all the way up to 5, and the reading will reflect that. And you have a couple error in, error outs. So going into the actual code itself, we have it separated into similar sections as the front panel that go in this order. If you want to pause and read that, you can, but I'll be going through all of it anyways. So first we open the links command and go directly into this while loop, what this while loop does is controls the wave of hallway lights at the beginning, the white LEDs that turn on sequentially. And it does this by using shift registers and case structure. So this case structure will remain false until this input here turns to be equal to 3. So it starts off as 0 and increments up by 1 every time the while loop runs. And also every time the while loop runs, this array function inputs this true to replace one of the falses. So first time it runs, it'll replace the 0 index with a true. Next time it runs, it will increase by 1. It'll replace the 1 index with a true, returning true, true, false, and then it'll keep going until it equals 3, in which case it'll go to the true case structure and print all falses. And each time this loop repeats, it just goes to this digital write that controls the lights. Down here we have the part that controls the actual sound, effect that plays during the beginning. We have a roll reveal sound followed by some footsteps, and the way we timed that was by using this flat sequence structure, and had the first frame of it wait for about 1.5 seconds and move on to the next part, which just plays the sound. It inputs the stuff from the front panel, samples per read, start position, and takes the song location and simply plays it until it is over. So it stops once the file has ended. And all these other sound effects will operate pretty much identically to that one. Our next phase is the fan. Similarly, task complete sound works the exact same way. It takes the inputs, goes through these functions, stops once the file has ended. We start by turning off all the pins that are connected to the fan at first, just to ensure that they're all turned off for safety reasons and for timing reasons as well. Here we have a digital write that controls pins 3 and 4, and depending on how you flipped that boolean clockwise and counterclockwise on the front panel, that simply changes to true false or false true depending on which direction you want it to spin. And then we go right into this next for loop, which, as this comment says, it ramps up the fan speed by 5% every half second. So it runs 20 times, and every time it runs, it inputs the duty cycle, the I divided by 20 times. So it starts off with 0.05, goes all the way up to 1, and waits half a second between each of them. So this will run for a total of 10 seconds. And then once the fan has finished ramping up, it'll turn back off once again using the same thing as the digital write that we had at the beginning, the array of falses. And next we move on to our electrical kill, as well as the LED light flash. Once again, you have the sound clip playing through this part and ending once the file ends. So we start off by turning off the electrical lights so that we can time it better. And the way we timed it was by using elapsed time function. And basically what this asks is if the elapsed time is greater than or equal to 2, it'll return a true. And in the true case structure, the lights will turn off. So if the time is not greater than or equal to 2, the case structure will remain false, which will turn the lights on using this digital write. So what this ends up accomplishing is the lights in electrical remain on for the vast majority of the sound clip, and then flash off when the actual kill part of the sound effect happens. And then once we're done with that, we turn off those lights again using this digital write, and we move into this part, which is the joystick reading and printing of the LCD screen and controlling of the cafeteria lights. What we have here is a pretty large case structure that only does anything in the true case, and the true case occurs whenever the joystick reads an input larger than 4. So once you have pushed the joystick up enough to detect a number larger than 4, the cafeteria lights will turn on using this digital write, and the LCD screen will print using this imported Arduino function. This Arduino function uses the LCD text string that you input in the front panel, turns it into an 8-bit array, and then through some Arduino code that you specify its location using this number, it turns that 8-bit array or it prints that 8-bit array rather onto the LCD screen, and then outputs it so that it actually prints in front of you. And then once again plays the emergency meeting audio and ends once that audio is finished. And once that audio is finished, you turn the cafeteria lights back off and you close the links function, and that is the end of our display.